Yes. So your two examples are the Connie and the Oscar situation. Alright, so when I look at that list, we have 82, 86, 82, 84, 85, 84, 85. So the smallest is 82. Then we have another 82. We have an 84. I have another 84. What do I have? 285. Another 85, and then an 86. 1, 2, 3, 4, 5, 6, 7. Okay. So we have to calculate the mean, the mode, the median, the range, the standard deviation, give the 5-number summary. So how are we going to do this? We certainly can do it by hand. But if we go into our calculator, I'm just going to clear that out. We're going to go stat and edit. I'm just going to clear out my lists. Again, we're going to do one variable statistic, so try to use list 1 if you have it. So I'm just going to put the numbers in like they were. 82, 86, 82, 84, 85, 84, 85. So those are my numbers. Get those entered into your list. We're going to go to stat, calculate, one variable statistics. Calculator basically says, are you sure you want to do that? Yes, I'm sure I want to do that. So, X bar tells us what? That's a mean. We're supposed to come up with the mode. The calculator will not tell us the mode. So, in this particular list, do we have anything that occurs more often than other things? You can make an argument that 82, 84, and 85 are mode because there is an 186. But I don't know. You can do that if you'd like. Mode. There's an 82, 84, and 85. So I guess in this case they tie. But if they would all tie, we certainly wouldn't write those down. Next is a median. Now, what's the median in my list? 1, 2, 3 from the left, 1, 2, 3 from the right. There's the median, right? On the calculator, if you scroll to the bottom, in your 5-number summary, the median is also 84. Supposed to find the range. So let's write down the 5-number summary. Goes 82. What's next?
82.
82 again. What's next?
84.
What's next?
85.
And 86, right? So if you drew that would be your 5-number summary. So what's the range? How did you get it?
Subtracted 82 from 86.
So 86 minus 82 gives me a range of 4. So this data is fairly close together. So we did a mean, a mode, a median, and a range. Standard deviation we have to do yet, and we wrote down the 5-number summary. So back to the calculator. When you go to find these two numbers right here, the S of X, and that's a sigma, Greek letter, kind of looks like a cursive O. It's got an O with a little squiggly hat on top. But you want to write down the S of X. S of X stands for a sample. We're looking at a particular sample of the data, not a whole population. So we're going to write down 1.5. Go ahead and write down 1.528. So standard deviation 1.528. And that just simply tells us that, we'll talk more about that rule, but every time you move 1.5 away from the mean, or the median there, we'll go from the mean though. So 1.5, within 3 standard deviations above and below, you pretty much have 99.7% of your data. I'm going to have you do the second one. For Oscar, quickly put all those numbers down, just the same way we did it. Okay, so I start out, the blue numbers are just what was given to us. I did the red numbers, small to big. So sometimes with smaller piece of data, you got 7 numbers. It might be just as easy to do some of the questions by hand. Anyway, but if you enter that into your list, all this stuff can be done very easily. So mean, X bar, is what? If these were your test score averages, so what's the mean? Oh, 84. I thought you were saying 34. I'm sorry. Mode?
76.
Median?
84.
Range?
24.
24. Standard deviations?
9.5 and 1.
9.591.
Sorry.
91, something like this. Okay? And then 5-number summary. The minimum goes here. The maximum goes there. The median goes here. So on a 5-number summary, those 3 numbers really are done by what you've done up above. You can find a minimum, maximum, and a median very easily. The Q1 and Q3, if you did something like that, you don't use this number anymore. So what's the median of those bottom 3 numbers? Should be 76 for Q1, right?
Yep.
And when you look up here, the median between these 3 numbers then would be 94. So a 5-number summary is not too bad. So any questions on what we found? Now as a teacher, if these were test scores for a particular student, what is the data kind of showing us? This person is fairly inconsistent, right?
Yep.
However, 90, 94, 96. There are some times when they have very, very good test scores, right? So what's happening here? Right? So if I'm looking at this student, I go, wow, they have a lot of potential. So maybe these are times when their life isn't so busy and they have time to do some studying. Here, things are going on, sports, church group things, significant others, maybe they work, maybe their family took vacation, right? So they didn't have time to study here. However, this student, when I look at it, it's all, I can predict with almost certainty that they're just going to be right around that B minus score. They don't fluctuate. So whatever they're doing, they're staying real consistent. That's how the data you can start to compare things. So if we're going to do the box and whiskers pot together, you can kind of look at the numbers. We have to go from 82 to 86 for this one, 72 to 96. So I'm going to start with the tick mark at 72, and then 96, up there. So that was a spread of 24, right?
Oh wait, so we're doing one script plot above?
Well, I'm gonna show you how, what they're talking about.
Oh, okay.
I mean, those are fine to sketch them like we did up there.
I thought you were saying make two different ones for each one.
No, we're gonna, so am I in the middle there?
Somewhere.
Somewhat, okay, 84. Halfway between 72 and 84, so that's 12, so that's about 78. Halfway between 84 and 96 would be about right there, 90. So I'm just trying to get equal spaced tick marks. So those are every 6, and you could do a little closer if you want to go, that'd be 74, 76, 78, 80, 82, 86, 88, get it? You just want evenly spaced things. You don't want one tick mark spaced, 10 feet, and the other one 3 inches. Okay, here we go. So the blue one, I would put my 82 is here. Is that really 82? Did we?
Yeah, we
Yeah.
That's weird. 84, 85 would be right there, and then 86 is right there. That's kind of weird. It won't have a tail on it because the Q1 and minimum are the same number, right? So that's weird. Huh. All right, the red one then, 72 and 76 would be there, above 76. 84, 94, and then the tail. So by putting them on the same scale, you can see the consistency versus inconsistency very well. They both have median of 84, so they both are going to be centered around 84, but man, the student in red, you'd kind of say if those are test scores, you'd be like, hey, what's going on? Let's move you that way. Describe each graph as symmetric or skewed. Determine if there are any outliers. Show your work. List all outliers, if any. Okay. The red one is symmetric, right? And I guess the blue one, I don't know how I would describe that. You could say it's a little bit skewed left because things are pulling, like this part of the box is being pulled this way a little bit. So the box is stretched a little to the left, so you can say skewed left. But let's go back and look for outliers. All right, so I'm going to just go back up here so we can see the numbers. And I'm going to use these two boxes. So IQR. What is the IQR for the blue data right here? IQR equals
1.528.
85 minus 82. So the IQR is 3. What should I do with that number if I'm going to look for outliers? I should take 3 times 1.5, and what do I get? 4.5. So what I'm going to do is go to the top of the box and add 4.5. What happens when I take 85 plus 4.5? What do I get? 89.5. Do we have any numbers that are still bigger than 89.5? No. Go to the bottom of the box. Subtract 4.5. So what's 82 minus 4.5? Oh. 77.5, right?
Yeah.
Is there anything smaller than 77.5? No. I'm gonna pause it, and you guys are gonna work on that red data, Oscar stuff. I just want you to see if you can find any outliers for the red one. I'll go through the same work, but I just want you to work with somebody near you and see if you can figure it out. Here we go. So what is my IQR for Oscar? 94 minus 76 is what? 18. If I take 1.5 times 18, what do we get? 27. So if you take the top of the box and you add 27, 110, 121, right? So if I add 27, we definitely don't have anything higher than 21. Go to the bottom of the box and you subtract 27. So 76 minus 27 takes me to 49. And again, I don't have anything there. So in this case, neither of the data sets has an outlier. Okay, so then what they do to see if you can really understand things is they will ask you to come up with your own data set that will match the given information. So they want you to use 5 values. You have to have a mean of 15, it has to have a median of 13, and you can't have a mode. So somebody walk me through, what's one thing we should do?
Multiply 15 by 5.
That would be a good start. Take 15 times 5. To have a mean of 15 with 5 numbers, that means we have to total 75. Right? Good. That's one way to start. What else?
We can
Or
The middle number has to be 13.
middle number has to be 13 because that's the median. So let's put that in there. When you put 13 in there, just go back to your total here and subtract 13. So now I just have to fill in the rest of the values. The fact that there's no mode means I don't want to have 2 of the same number in this case now, right? We don't want that, so we probably want to have 5 different numbers. And basically the last 4 numbers have to add up to 62. So give me another number. I don't know. Can I go 10 and 15? Is that okay to write 10 and 15 in there? Okay, but now we should subtract 10 and we should subtract 15. So, excuse me, I'm really subtracting 25. What's 62 minus 25? 37. So I'm gonna bring that up here, so you can see it. So now my last two numbers have to add up to 37, right? So let's make the next number an 8. 37 minus 8 looks like 29, so what's going in the last spot?
29.
29. Now, what are the chances that you have the exact same data set as the person sitting next to you?
Very unlikely.
Slim to none. This is a hard problem for me to correct on an exam. Because I have to actually go through and see what work you did, but it has to fit the data. Okay, so on the exam you will have some problems like this. Come up with your own data set and make it fit the different landmarks, if you will. So I'm going to give you a second here to do part B. So I'm going to pause it, 6 values. The mean is 24, the median is 25, and the mode is 28. So what I'm going to do is pause it, you're going to work on it. Then I'm going to ask for some examples. I'm going to put them up on the board, and we're going to look at them and see if they do indeed work. Alright, so with the 3 examples we have written up here, what I need you guys to do is, if you're on that side over by the iPad cart, add these up. If you're in the middle rows, add these up, and if you're over here by the chalkboard, add these up. First total? What?
444.
144. Second total? Second total, people in the middle? They got 144? Third total? Okay. So when I go to correct these, that's exactly the same thing I do. I make sure that all your numbers add up. So I have to go through all your numbers and add them up and make sure they hit the number you're supposed to. So 24 is your mean, and so on this problem you should have started out taking 24 times 6. Correct?
Yep.
48, 48, 48. Okay. Then I would go back and I'd look for the median. So what I do is this is a set of 6 values. So I look right here. Do these two numbers, what am I checking? What am I going to look for? Do they add up to
50.
50? Because the two middle numbers to get a median of 25 have to be an average of 25. So 22 and 28, 22 and 28, 24 and 26. All 3 of those add up to 50. So the median will be 25. Great. Then the last thing I'm doing is I'm looking for a mode of 28. So this person has 2, 1 of everything else. This person has 2, 1 of everything else. This person has 2, 1 of everything else. So those data sets are working. Perfect. So the question is, do you have to put them in order? No, you don't. But if you don't, what I've seen Patricia, what people do is they start out by doing, let's say they do 24 and they do 26, right? So they put their median in, and then they go, well, I'm going to put maybe a 20 here, and then they go a 28 here, and then they do a 15 and maybe a 6 or whatever. What really is the median of that data set now? What's the median now because I put them in order like that?
22.
So what happens is if you're not careful as you're putting stuff in, the median switches on you. So yeah, I would put them in order. That would be the easiest for you. Alright, so if you look down there, the assignment, it's a little bigger because remember this is 2.1 and 2.2 combined, but with the calculator work, things go a little bit faster, so you should be able to get it done.